Today our topic is periodic classification of elements. What is periodic? A periodic table. We have one well-known table we are calling as periodic table. What is meant by periodic table? Periodic table means we have 118 elements. Arrangement of these elements. Arrangement of these elements. These elements in a tabular column, in a table is known as periodic table, So we have so many types of periodic tables they given, but the successful periodic table is what we are still following, that is the successful. Before that, when we are following this table, before that so many scientists given different types of periodic table. Now we are going to see 2 or 3 periodic tables. What are failed periodic table also we are going to see. Number 1, Dauvernier periodic table. Dauvernier periodic table. According to the Dauvernier periodic table, he arranged 3 elements. For example, I can take as X, Y, Z. 3 elements in a row. So 3 elements are there, so it is called as a triad. So this is a famous with Dauvernier triads. Dauvernier triads. Triads means 3 elements. 3 elements arranged in a row. What is his rule is? Rule is atomic weight of he arranged these elements increasing order of atomic weights. Increasing order of atomic weight. Increasing order of atomic weight. This is, he followed that to arrange these elements means X is having some atomic weight, Y is greater than X atomic weight, Z is more greater than Y atomic weight. So he arranged in the order of increasing order of atomic weights. Rule of his Dauvernier triads is atomic weight of middle elements. Middle element means Y is equals to the atomic weight of X, atomic weight of X plus atomic weight of Z by 2 means what is the meaning? Atomic weight of middle element is the arithmetic mean of the remaining 2 elements. That is his rule, but it was a failure. His periodic table was a failure due to all the elements we cannot arrange by this rule. All elements cannot fit for this rule. So that is a Dauvernier triads. Second one is Newland octaves. Oct means we know that 8 electrons. So this is also based on increasing order of atomic weight. Increasing order of atomic weight only. He arranged 1, 2, 3, 4, 5, 6, 7, 8 like this. He arranged the elements in a row. He said that what is his rule is first element and 8th element, 1 and 8th element, every 8th element has similar properties, like as musical notes. Musical notes means sa, re, ga, ma, pa, da, ni, sa. Again, first sa, it will start with sa, and eighth note also sa. How they are similar to each other, like that first element and eighth element has the similar properties, like as musical notes. It is his rule, but he arranged the elements based on this rule, but it is also failed. What is the reason? Up to 20 element, his rule is a following. After 20 elements, they are not fit for this rule. So that is his failure. After that, we are going for Moseley's periodic table. Third periodic table is Mendel's periodic table. Mendel's periodic table. This table also periodic table. This table also based on increasing order of increasing order of atomic weight. Increasing order of atomic weight. But he arranged how many elements are there on the time of in his periodic table is 63 elements are there. 63 elements he arranged increasing order of their atomic weights, and he arranged in vertical columns and vertical column and horizontal column. Horizontal column. Vertical column we are called as a group. He given the name for vertical column as a group, and horizontal column as a period. Means in his periodic, for example, if we take like this tabular column, he arranged this column is called as a period, and this is called as a group. That is the difference. So from top to bottom we are calling as group, from left to right we are calling as a period. And in his periodic table, 8 groups and 7 periods are present. 7 periods, and he divided the groups into A and B. For example, if we take this is a first group. If we take this is first group, here he divided into 2 parts. This is 1A, 1B, like that. 1A, 1B, like that. He divided the group into A and B also. So 8 groups he divided into 8A and 8B. Total we can count as 16 groups, but we should not call as 16 groups, 8 groups only. And he arranged the elements, based on their chemical properties. What is meant by chemical properties? For example, if we take some reacting with another elements. For example, if we take sodium is there, sodium or magnesium. Magnesium is reacting with oxygen is able to form MgO. So for example, magnesium you can take as M, oxygen you can take as O. MO type oxide it is forming. The general formula we can take as MO. He arranged in these 63 elements, which elements is able to fit for this general formula. Those elements he arranged in a group. So in these 63 elements, which elements are fit for oxide formula with MO, he arranged those elements in a group. And if you take aluminum reacts with oxygen, it can form Al2O3 type oxide, means M2O3 type oxide. So the elements which are fit for this formula he arranged in a same group. Like that he arranged the elements, and he left some space. He left some space for upcoming elements, and at last group, at end of the periodic table, one group left for noble gases, because noble gases are not discovered on that time, but he left one group for noble gases. And what are the elements? Some elements he given the properties. Some elements he given the properties before their discovery. He given after the boron, he given the name Eka boron. Means boron is there on that time, but after boron he thought that next element which is discovering the new element, that element also having some properties. Based on that he given the name with Eka boron, means after boron. And Eka aluminium, and Eka silicon. After that they given the name for Eka boron is scandium, gallium and germanium. These are the elements. He left some space by before he thought that some properties are there, just like as a boron, just like as aluminum, just like as silicon, so that he left some space. This is Mendeleev's periodic table. But what is his failure? What are the failures of Mendeleev's periodic table? One more thing, before going to the failures, he corrected boron atomic weight. He corrected boron's atomic weight. Before that it is having 13.5, but actual boron atomic weight is 9. He corrected that atomic weight. And what is the failure? Failure means number 1, based on atomic weight he arranged the periodic table. And isotopes. What is meant by isotopes? In atomic structure we already discussed. Same atomic number and different mass number, means mass number is different. Mass number is different means H11, H12, H13 is there. Same element with 3 different atomic masses. And these atomic masses, his periodic table is based on increasing order of atomic weight. So 3 elements has to get a different place in the periodic table. That he doesn't explain. So this is the failure of Mendeleev's periodic table. And no exact position. Of course, still now that is the problem. No exact position for hydrogen. No exact position for hydrogen. These are the failures of Mendeleev's Mendeleev's periodic table. After that, after the Mendeleev's periodic table, now we are following the correct periodic table. Which we are following successful periodic table is Mosley's periodic table. This Moseley's periodic table also can called as a modern periodic table. Modern periodic table. Modern periodic table. In this modern periodic table, it is a following. It is based on, till now we have seen, based on increasing order of atomic weight. Till now we have seen, but the Moseley periodic table is increasing order of atomic number. Atomic number increases, he arranged in the periodic table. And in this periodic table, he follow the periodic law. What is meant by periodic law? Periodic law means the chemical properties, chemical and physical properties. Physical properties. Chemical and physical properties of elements has periodic change based on their atomic number, If you see, actually, five, six, seven periods are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 periods. In this, if you take, here also, what is periodic law? We will explain after knowing the periodic table. This is modern periodic table, and bottom of the periodic table, again 2 columns also will be there. These are the so these 2 columns also separated. Why they are separated, that and all we will discuss. These 2 columns also separated. This is the whole modern periodic table. So same like as a Mendeleev's periodic table, horizontal lines we are calling as horizontal lines, horizontal columns we are calling as a period. Very good. And vertical lines we are calling as groups. Now in this periodic table, how many periods are there? How many groups are there? How many periods are there? 7 periods and 18 groups. 18 groups. So 7 periods and 18 groups are present in modern periodic table. And what is the success of this periodic table is based on their electronic configuration. We already discussed that this is, he arranged the element, Moseley arranged the element based on increasing order of atomic number. Not only like that, based on their chemical properties, he arranged the elements based on their chemical properties, means reactivity nature also he observed, chemical properties, and very important thing is electronic configuration. Electronic configuration means, if you check the electronic configuration means nothing but valency configuration. Valency configuration for all these elements is same. For all these elements, same. In a group, the valency configuration is the same. And the nature of reactivity nature is the same. If this is in this group all are metals, in this group all are gases, in this group all are non-metals, very few properties they are changing. Very few properties they are changing, but he arranged in a successful manner based on their chemical properties and physical nature also, and based on electronic configuration, based on electronic configuration, based on period, not based on periods. If you take periods, how many periods we discussed? 7 periods are there in modern periodic table. If we take first period is having only two elements, right? Second period 8 elements. Third period 8 elements again. Fourth period 18 elements. Fifth period again 18 elements. Sixth period 32 elements. Seventh period still incomplete. Still incomplete. Now if you see 2 elements, so this is called as shortest element, right? These two are called as short periods, not shortest element, shortest period. These two are called as short period. How many short periods are there? 2 short periods. This is a long periods. 2 long periods are there, 18 elements, and which is having 6th period, means which is having 32 elements, that is called as a longest period. And 7th one is incomplete. Based on number of these elements, easily we can find out. If you know any atomic number in this group, based on this number of elements in the period, you can find out easily atomic number of next. For example, here I am taking hydrogen. Hydrogen atomic number is 1. What is the next element? This is in first period. Atomic number 1. In first period, how many elements are there? 2 elements. So plus add 2. Next atomic number is 3. If you don't know the elements, not a problem. You can get the atomic number 3. Okay. In second period, this is a first period, second period. In second period, how many elements are there? 8 elements. 8 means what is that? 11. Atomic number is 11. In third period, first 11th element is the first element. Next, how many elements you need to add? How many elements are there? That many elements you need to add. 8 elements means 19. In fourth period, first element is 19th element. 19 plus 18. 19 plus 18. 37th element. Atomic number we can find out. 37 plus 18. 37 plus 18. 4. 65. 65. Or 55. 55. So, next element is a 55. 55 plus 32. 55 plus 32. 87th element in next period. So, we can find out the atomic number of the element, what is in next. They may ask the question by giving sodium is present. Sodium already you calculated. Magnesium is present in second group and second period, not second period, third period. Magnesium is present in second group. It is present in second group and third period. What is the element of second group and fourth period, not fourth period, 6th period, they may ask the question. They may ask the question like that. In 6th period, how can you find out? How can you find out? Magnesium atomic number, we know 12. Magnesium atomic number 12 means it is present in 3rd period. 3rd period, how many elements you need to add? 8 elements, means 20 element is present in 4th period. We don't want for 4th period. Again, you need to add 18, means 38th element is present in 5th group. We don't want that also. 18 means 56th element is present in 6th group, 6th period. That is the way to find out the atomic number of the elements which is present in next group or next period. Wherever it may be, you can find out easily by knowing one atomic number. Any one atomic number. This atomic number you know, so that you can find out this one. If you don't know this atomic number, we cannot find out the remaining atomic numbers. And next very successful next arrangement in this periodic table is based on atomic, not atomic, electronic configuration. Electronic configuration. He divided this periodic table into 4 parts, 4 groups, 4 blocks he divided. 4 blocks he divided based on their electronic configuration. Electronic configuration means a valency electronic configuration. Valency electronic configuration. So what is that? Number 1 is S block element, S block, P block, D block. We already discussed what is SPDF. SPDF are orbitals where the electrons are rotating. So in S block element, in S orbital, it can accommodate into 2 electrons. It can accommodate only 2 electrons. P orbital can accommodate maximum 6 electrons. D orbital can accommodate maximum 10 electrons. F orbital 14 electrons, that we know very well. So that in S block 2 groups are present. You can remember very easily. S orbital accommodate 2 electrons, so 2 groups. P block can accommodate 6 electrons, so 6 groups. D block 10 electrons to 10 groups. F block 14 electrons, so 14 groups. 14 groups are present in this periodic table. Now we are going to know about each block. In these first 2 groups, they are called as S block elements, because their configuration is S block, belongs to S block. What is that? We will discuss. And the end 6 groups are P block, belongs to the P block elements. And in between 10 groups are there. In these 10 groups are there, that is D block elements. And at the bottom of the periodic table, 2 columns are there. Now it is not calling as a group. Now 2 columns are there. They are belongs to the F block. They are belongs to the F block, because here 14 groups will be there. This is 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 groups are there. So these 14 groups means nothing but vertical columns. So vertical columns are 14 are there. Those 14 are belongs to the F block. So based on electronic configuration, they are divided into like this periodic table. Right. Is valency electronic configuration. First we need to know about valency electronic configuration. Till now, what is that? For example, magnesium is there. Magnesium. Magnesium atomic number is 12. So what is the configuration? In atomic structure, we already discussed the configuration. 1s2, 2s2, 2p6, 3s2. This is 2 plus 2, 4, 6, 10, 12. 12 electrons are there. This number indicates the number of electrons. Okay. What is the valency shell? Valency shell means the final shell, last shell. This is third shell. What are the shells are there? First shell. This number indicates number of shell. This number indicates number of electrons. So, first shell, second shell, third shell. Right. In final shell, what is the final shell? Third shell. In third shell, how many electrons are there? 2 electrons are there. This is called as valency electrons. Valency electrons, this one. This 3s2 is called as valency configuration. Valency configuration. I hope you understand. And one more example I am going to give. For example, potassium. For example, potassium. In this potassium, 19 is the atomic number. 1s2, 2s2, 2p6, 3s2, 3p5. Is it correct? 10 plus 7, 17. No, 3s2, 3p5. No, 3p6, 4s1. Right. 10, 19. Right. Now, what is the valency shell? First shell, second shell, third shell. This is fourth shell. Fourth shell is valency shell. Now, what is the valency configuration? This one, 4s1 is valency configuration. For example, chlorine. I am taking chlorine. Chlorine 17. Configuration 1s2, 2s2, 2p6, 3s2, 3p5. Valency electrons I want and valency configuration also I want. First shell, second shell, third shell. This is. So this is valency configuration. So 3s2, 3p5. 3s2, 3p5. Number of valency electrons. How many are there in valency shell? That is so 7. This is the way to find valency electrons and valency configuration. If you observe here, in valency configuration, the last electron means in p orbital, 5th electron, where it is going? In which orbital it is going? P orbital here. Here where it is going? P orbital. Here where it is going? S orbital. Here where it is going? S orbital. So, based on this valency configuration, he divided into 4 blocks. If valency electron means last electron, enter into S orbital, they are belongs to the S block. If valency electron enter into p orbital, they are p block elements. D orbital, D block elements. F orbital, F block elements. Now, this is the valency electron enter into which orbital? S orbital. So, this element is belongs to the S block. Here S orbital. So, it is also S block. Here p orbital. So, it is p. If it is D block element. Like that, he divided into 4 blocks based on their valency configuration.